A very good morning to everyone. My name is Devendran and my metric number is EA18073 and I'm from assignment group B, and my group is going to present about shift and rotate instruction set. So in that I'm going to explain about arithmetic shift operation. So as you can see in the slide here, there are basically two types of arithmetic shift, which is arithmetic shift left and arithmetic shift right. So when we look at arithmetic shift left, arithmetic shift left of one position moves each bit to the left by 1. So as you can see in the example below, when we perform left arithmetic shift, the MSB bit will be discarded and the LSB bit will be filled with 0. So as we can summarize that, arithmetic shift left is equals to logical shift left. Okay, so when we look at arithmetic shift right, arithmetic shift right of one position moves each bit to the right by 1. So in here the LSB bit is discarded and by one position all the bits is shifted to the right. Okay, so the MSB will be empty and the MSB will be filled with available MSB or the previous MSB bit. Okay, so let's say the MSB is 1, so all the bits will be filled with 1. If the MSB is 0, then all the bits will be filled with 0. Okay, and now we will look at two examples of arithmetic shift right operation. Okay, so as you can see in the first example, the MSB bit is 0. So when we perform arithmetic shift right by 4 digit, all the 4 digit will become 0. So in the second example, the MSB bit is 1. So when we perform arithmetic shift right by 4 digit, all the 4 digit will become 1. So this is how it works. And one more important thing is that the value 0 represents as positive value and the value 1 represents as negative value. So as you can see in the first example, the MSB bit is 0, so it represents positive value, and in second example the MSB bit is 1, so it represents negative value. So that's all from me, and thank you.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Johan Visitin. So, today I want to share about the LSR, which is logical shift right. So, the instruction is same like the move instruction. We shift just open. So, yes, instead of the LSR is S. So RD is the destination of the operand. RM is the how many the bits will shift. So as an example, the instruction is the LSRS hashtag 02, T2 80. So hashtag 02 is the number of bit will shifted to the right, then D0 is the destination. So as an example, we will take B2 as an example. So B is 1011, 2 is 0010. So when it shifted 2 to the right, it will become 001011 00, which is it will become hexadecimal of 2C. So same number, so same thing will happen to other if it want to move 3 to the right, 4 to the right, it will become the vacancy will fill with 0. So that's all I think. Thank you.
Hello, my name is Paulson Yu, and I'll be covering replacing Nafisa for the logical shift left, as our member has been down with the COVID-19 recently. So here we have a register with the 32-bit numbers, and in the value is 1 in binary and also 1 in hexadecimal. So we are applying logical shift left, or known as LSLS function, which its function is to shift the numbers in the values here by the number applied to it. For example, in this case, we are using LSLS immediate 3. So this number is binary 1, also decimal 1. Applying LSLS immediate 3 would cause it to shift by 1, 2, 3 into the fourth space here. And as you can see, here it's in the fourth space. Hence, it will be hexadecimal 8. So if you were to apply LSLS immediate 3 again, it will move from 1, 2, 3 to the left. 1, 2, 3, there, number 7. Hence, the hexadecimal value is 40. So the LSLS function is a quite simple one, where it just shifts the values by immediate values shifted to it. Here's another example of LSLS, where we have a number here, a register with a number 8888 hexadecimal, or 1000 1000 1000 1000. So applying LSLS4, all of these bits will shift to the left by 4. So for example, this will move to 1, 2, 3, 4 into the space 20, which is here. This would 1, 2, 3, 4 into 16, here 16, and same for the 8 would go to the 12, and 4 would go to the 8. And as you can see here, the result will be here, where the hexadecimal value is 88880.
Okay, I will explain about the RORS. So RORS is the instruction stand for rotate right. This instruction rotate the mentioned bit in the register to the right side one by one, such that rightmost bit that is being rotated is again stored as the MSB in the register, and it is also stored in the carry flag. Okay, as example, we have 32 bits. So this is a bin data. I will take a randomly, pick a randomly. So how the RORS is functioning? So RORS is functioning like we move the data, we move the bin data. Like example, we move for 3 bits. 3 bits. So it will shift, the bin data will shift to the right. So it will shift 3 bits. So it will shift 3 bits. So we have extra here. So how carry flag can be occur? So carry flag is the last bin data. So last bin data is 1. So it will be carry flag, it will be 1. So after that, it will copy and put at the in front. So here is the result. So 101 is the, it will put to the in front. So this is the new bin data when after we rotate the we rotate. So that's all. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. Today I want to show to you how the arithmetic shift operation, which is arithmetic shift to the right and logistic shift to the right, works. Here's the coding. We write, okay, we compile and we debug. Okay, so first we load the data into the register R0. Here's the data 0x00040. So we execute, and then we execute also Okay, this arithmetic shift to the right R0 with immediate 2. Immediate 2 means that we want how many bits we want to move. Let's say this is immediate 2, so we want to move to the right with 2 bits. Okay, let's take a look for the example. Okay, here's the example 0 at 0040, and we want to move 2 bits. So this is a number of bits, and this is a binary for 00040. Okay, 000 we change to the binary, we get the 0000, this 4, and this one is 0. So we move to the right with 2 bits. So we move to the right with 2 bits. So this place will disappear. So we want to fill the number of 2 bits. Will follow the last bit of the number. Let's say this number, the last bit of this number is 0. So these 2 bits will follow this bit, last bit. So it will be 0, 0. And then we got the uh, new data, we got 000010. So this is these two number of bits will follow, will be in carry flag, will be updated in carry flag. Okay, so see, okay, so we execute. So yeah, we can see the zeros, the number of new data we get 00010. So the carry update will be 0. So and we execute this one. Okay, this show for the negative number, negative sign bit number. So we see in this example, this is our data FF00020. We want to move 3 bits. So this is a binary FFF0020. We move 3 bits to the right. So the sign bit is 1. So we move, we get this. So this 3 will disappear. Then the number should place here will follow the last bit of the number. So the last bit of this number is 1. So the rest will be 1. And this same also, this 0 will update in carry flag, and this will disappear. So we get the new data 0x FFE00004. So try to execute, and then we get FFFE0004. Then carry will be 0. Okay, for logistic, shift to the right. Okay, we execute, we look the data first. Okay, this is a logistic shift to the right with 3 bits. So this is the number of the data E0x EA00020. So we want to move 3 bits to the right. So this is a binary. We change EA to binary. We got this 0111000, and then the operation was us to do logistic shift to the right. So we move 3 bits to the right. It will be like this, and the 3 place here, 3 bits here, not follow the number of last bit. Here there is a difference from the arithmetic shift to the right. This number of the number of the last bit is 1, but the 3 here not follow the last number, logic 1. If this one, then the rest will be 0. So the others is same. This will be update in the carry flag, and this will disappear. So here we get the new data, which is 1D400004. So we execute. So okay, we get the data 0x1D40004, and the update carry flag will be 0. So that's all from me. Thank you.
So this is the demonstration of the coding for LSLS, where it will be the same as the presentation on the Excel sheet. So at first we have LDR R0 by 1, just as the example, and then we will left shift by 3 and by 3 again. So here we go, R0, load 1, then shift by 3, it will become 8, and shift by 3 again, it will be 40 hexadecimal. Okay, next we have the LDR into register 1, 0, 0, 0, 0, 8, 8, 8, 8, and then we're going to apply LSLS 4, and the expected result is 8, 8, 8, 8, 0, just as the example. So load, and then shift, there. So as explained by my teammate Alif, the function RORS rotates the value from the right side to the front side. But for example, in this example, we'll be using RORS by the value of 3. So it'll be taking the last bottom 3 bit from this register and rotating it to the right by 3, where these 3 bits will be moved to the front over here. Meanwhile, the rest will be shifted to the back. So the hexadecimal number is this initially, and the expected result would be this. So here on the simulation, build, debug, and first we load the first hexadecimal number into the register 0. Then we load the value 3 into register 1, which will be used for the RORS. So we start with loading R1 with the hexadecimal number, R0, then R1 by 3, which will be used for the operation. Then RORS, R0, R0, R1. So it'll be using the value of R1 for the operation. So this will rotate to the right by 3. So here, and this is the expected value, which is true.